Yes, hi, this is Bernard Brault with OTN Systems. This video is part of a series where I'm showing you how to configure and provision an MPLS-TP network with Xtran using the TakeCare management platform. So what you see here is the network, and it looks like a number of different rings. Actually, they're not actually rings. It's a fairly mesh network, even though it looks like a hybrid between mesh and rings. But what we are going to do in this tutorial here is show you how to do a teleprotection service. And teleprotection tends to be sort of adjacent sites because that's where the transmission lines are and the relays, the protection relays are. So let's assume here that we have to do two teleprotection services. First one will be between node 4010 and node 4020 right there. And obviously here we have a nice ring, so there's two different paths, so we could use this primary path and this as a backup path. That's pretty nice. The second one we're going to do is between site 6010 and 5030, which is not as ideal because we obviously going to have to go across and hit basically two single point of failure, which is node 5040 and node 6060. So even though we're going through like a single point of failure right there, we're going to try to make those as reliable and redundant as possible. Alright, so this first video here, the first thing is actually make sure that we have a tunnel between those two sites. And one way to verify this would be to go to the Network tab and to highlight basically node 4010 right there. And as you can see, 4010 only has a subring right here. And this subring right there is, let me see if I can visualize it, so show the related element. So this is part of a subring system, and that's certainly not sufficient because subrings are for Ethernet traffic. They're not point-to-point for teleprotection. So we're going to need to create a protected tunnel or two separate tunnels between node 4010 and 4020. Let's go to the connection tab to do this. And let's create a tunnel, and this time it's going to be 4010, 4020. All right, point to point with protection. And the next step is to actually select the two endpoints of the tunnel. The primary path, so let's choose the short path as a primary path and use the long path right there as a backup. Let's zoom in a little bit more, just make it easier. And BFD sessions, LSPs. This is a summary of the tunnel that we're creating. As you can see, it's point-to-point, primary path, and the backup path, and we're done. So here's the tunnel that we did. Now let's remember we need to create another service. This time it's going to go across these two nodes right there, and as I mentioned earlier, that these nodes we're going to have to make them as redundant as possible. So the best we could do is basically make all the electronics and the hardware redundant. So let's go and take a look at node 5040 and 6060. Alright, so that would be a network hardware. So I said 5040, 6060. 5040 right there. Let's take a look at it. This is what it looks like. It does have the, as you can see, the C3794 module inside of it, but it doesn't have a redundant core switching fabric. So we're going to add this core switching fabric right here. And obviously by doing this, it's not physically adding it out in the site, but it's provisioning it and basically I'm gonna get, if the module is not inserted, I will see this in my alarm, because I'll have a mismatch between what I have configured and what's actually physically out there. So this is node, and we said 6060 right here, and we're gonna do the same thing. Go to edit this node. As we can see, we do have redundancy in the power supply, and we're going to add a redundancy SM module. Alright, so that's done. Let's get back to the connection tab. And this time around we need to create a tunnel between basically these two sites. So let's create tunnel. I like to give it a meaningful name, 5030 to 6010, and point-to-point with protection. Next. Alright, let's blow this up, and it's going to be from here to there. And how are we going to get there? So let's use a primary path, sort of a short primary path. And we don't have too many options for the backup path, so it looks like we're going to have to go around the ring here, use the secondary link that we have, and then work our way. There's not too many options unless we deploy additional fiber, which is always a possibility. It'd be nice to have fiber right here and use this here as a backup path. I'm pretty sure if this was a important transmission line that this project would have some viability. Alright, so next, label switch, and we're done. Okay, so now we have the for this teleprotection service, we have this tunnel selection. So here's the primary path, and here's the sort of long winding backup path, but that's the best we could do. And by the way, you don't need to worry about the it takes about, of course, the delay across this long path here would be about 8 microsecond per kilometer for the fiber delay. And the delay, the pass-through node delay, is around 10 microseconds. So really, all you need to worry about is whether or not the fiber delay is long enough. And typically will be for most scenarios. Okay, so now that we have our tunnels, let's attach services. So we have this right here. Let's call this... let's say it was transmission line 125, and it's going to be circuit emulation. C3794 would be typical for differential protection. And let's have the site selection. So we're going to pick this here, and we do have a C3794 card right there with 2 ports. We'll pick port number 1. Same thing here, port number 1. The next step is, whoops, sorry, I think I clicked on the wrong card. There you go. Next step is to actually select the tunnel, and we did create a tunnel down here, if you remember. That was the tunnel right here. And so that's a packetizer. I like to use basically, the more TDM frames per packet, the less, the longer the delay, but less amount of bandwidth to consume. This is teleprotection, so 2000 is a good choice. It gives me a delay of about 1.3 millisecond of delay, and plus the fiber delay. All right, next is this going to be a top priority. Notice that you cannot use priority 5 for Ethernet frames, only for protection and TDM traffic. Here's a summary of what we're doing. So basically, this is the service interface 9 port 1, which is C3794 at each end, using this basically protected tunnel in the ring 4000 if you want. And sort of wire, and we're done with this one. Alright, it was that simple. Let's take a look at it. Here's line 125, right there. All right, and let's create the second one right away. We will look at both of them a bit later. All right, so let's create another service. Let's say this is line 138. Circuit emulation, C37, same thing. Well, actually, you know what? Why don't we make this one mirrored bits? All right, so that would be serial and 9600 baud, and it would be between those two sites right here. So here's the serial card. We're going to take port number 1. Same thing there. And this time around for this service, the tunnel we're going to pick is this one. And if you remember, this was a long winding way around where we didn't have any choice, the tunnel that we created earlier. Again, we're going to make this a 2000, so 2 TDM frames per packet and 2 milliseconds the jitter buffer, and the priority is going to be 5. Summary of what we're doing. And all right, so we created these two services. If we go into the network tab now and zoom out a little bit, I could see that I could visualize a line 125. Here's a line 25 service showing me it's a C3794. And if I look at the line 138, it's showing right here. Alright, so I hope you enjoyed this little video. Thank you very much for watching.